Hello students, my name is Emma Reed. I am an 8th grade math teacher, and today we are continuing our Unit 8 on the Pythagorean Theorem and irrational numbers. And today we are on day 18, the converse, part B. And our big question for today is how can we use the Pythagorean Theorem to determine if a triangle is a right triangle? So before we move away from this page, I want us to take a moment and think about this concept of the converse. And we're also going to come back to this at the end of the lesson. So the word converse has two parts. And the first part, con, is a word you might be familiar with if you speak Spanish or someone in your family speaks Spanish or your friends. And con in Latin languages means with or together. So we have with or together, and then verse usually means something like a turn or a change. So you can think about reverse or inverse, you may have heard in math. So converse is taking something and turning it on its head. So in logic, we say if P, then Q is true. And when we take the converse of that, we're saying if Q, then P. So we're asking ourselves, does this statement, this mathematical, logical truth, work in the opposite order? So as we go through this lesson, we're going to be asking ourselves that question about the Pythagorean Theorem. Keep this big question in your head. How can we use the Pythagorean Theorem to determine if a triangle is a right triangle? As we move together to our introduction/launch. Here we are on slide A, and we are looking at three different triangles. We have triangle X, triangle Y, and triangle Z on the left. And we're going to read the prompt together. Please read along silently while I read this out loud. The side lengths of triangle X, Y, and Z are listed. Determine if each triangle is acute, right, or obtuse. In right or obtuse triangles, identify which side length is opposite the right or obtuse angle. So take a moment to think about whether triangle X, Y, and Z are acute, right, or obtuse. And when you're ready, explain your thinking in the blue box. Once you've had enough time to express your answer to the intro/launch, hold in your mind what did you notice about the side lengths of each different type of triangle. And we'll move together onto slide B to start our explore section. So on slide B, we are looking at these two triangles, and given the information provided for the right triangle shown here, find the unknown leg lengths to the nearest tenth. So we're told that these are right triangles, and find our missing leg lengths. Pause and think. Once you've had enough time to do your thinking and come up with your answer, take a moment and make sure that you follow the directions about how to round your answer. You should be rounding the value to the nearest tenth. Put your answer in the blue rectangle, and we'll move together to the next section of our explore, which is slide C. And on slide C, we have another triangle, and this time we are told that the triangle shown here is not a right triangle. What are two different ways you could change one of the values so it would be a right triangle? Sketch these new right triangles and clearly label the right triangle. So take a moment to pause and think about this. You're looking for two different ways to change one of the values so that we could make this a right triangle. And once you have your answer here, we're going to think about another student's answer, and you're going to decide if you agree or disagree with what they did. Okay, so now before we move on, imagine that a student replaced the length of 6 on the longer leg of this triangle with a length of 5. Is this student correct or incorrect that they have made a right triangle? How do you know? So you don't have to write your answer to this one. You may want to do some calculations to the side. But decide for yourself, is this student correct? Have they created a right triangle? And how do you know whether they've created a right triangle or not? So pause and think about that. And when you're ready, we'll move ahead to slide D, the last slide of our Explore section. And on slide D, now you're going to answer the question, is this a right triangle? How do you know? So think back to that other student's work. What steps did you need to take to know whether that student was correct? And you can use some of that thinking and those steps you came up with to help you answer this question here. And you want to have clear, precise proof for your reader. Whether this is or is not a right triangle, you want to back up your thinking with math evidence here. So pause, record your thinking in the blue rectangle. When you're ready and you feel that you have a convincing proof on slide D, we'll move together to our summarize section. And here's where we're going to think back to our big question, which was how can we use the Pythagorean theorem to determine if a triangle is a right triangle? And this is where we connect back to that idea of converse. So we know that if we have a right triangle, then a squared plus b squared equals c squared, or the square of the legs summed together equal the square of the hypotenuse. Now, in the previous slides, we asked ourselves the question, does the Pythagorean theorem help us prove that something is a right triangle? So as you prepare for this summary, think about that question. Did the converse help you for this lesson today? And use the space on the right, as always, to record any notes that you want to remember for the future. Again, I am Emma Reed, and thank you for joining me today.